Molecular process. It is a unimolecular physical process. Unimolecular physical process. What it means? Means single molecule involved. Whenever any molecule is de-exciting, it never combine with other. Okay, only one molecule is going to be affected. That is called what? De-excitation, unimolecular process. This point asked in exam. Which among the following processes is a unimolecular process? De-excitation or deactivation. Okay, so we can also write like this: reaction paths, and this is energy. So this is ground state, it will absorb energy and reaches to exit state, and if it is not giving any product, then it will come back to ground state. Whenever if it is come back to ground state without giving any product means this is called de-excitation. This is de-excitation, and this is going to release energy. It is going to release energy. So whenever if it is coming back to ground state, that is called de-excitation process. During that particular process, it is releasing more amount of energy. So here you write, they loses excess energy. So this downward process is called de-excitation. So when molecule is returns from excited state to ground state, during that time it will release some energy. So when they returns to ground state is called de-excitation or deactivation. It is a unimolecular physical process. Single molecule involved in de-excitation, multiple molecules will not involve. This is possible only when if excited molecule unable to give product. If excited molecule not giving product, on the time it will come back to ground state by releasing energy. So now this is called de-excitation. De-excitations are generally two types. Non-radiative, one more is radiative. See, de-excitations are classified into two types. Non-radiative, radiative. De-excitations are classified into radiative and non-radiative. So non-radiative, nothing but thermal. This is thermal and this is emission, otherwise light. Radiative means light, non-radiative means thermal. So non-radiative further classified into three types: vibrational cascade, internal conversion, inter-system crossing. I will write separately. Right now you write down VC, IC, ISC. Non-radiative thermal process are three types: vibrational cascade, internal conversion, inter-system crossing, ISC. You write direct abbreviations, that words I will explain later. Okay. Now radiative two types: fluorescence, phosphorescence. Total 5 things we are going to learn now. De-excidations are classified into two types based on the loss of energy forms. So that may be a non-radiative by liberating thermal energy, heat energy, or by liberating light energy. System is get heated, system appears one light. So this is called thermal and this is photochemical. Returning of excited state molecule into ground state by releasing energy in the form of heat is non-radiative. Returning of excited state molecule into ground state by releasing energy in the form of heat. Here key point is heat only. That is called non-radiative thermal process. This side is over. So don't write this, just you see this. I will give time, then you write down this one. So this is S0, now converts into S1, and this is V0. Then 1, 2, 3, 4, V1, V2, V3, V4. Now I am giving S2. This is S2, and V0 is here. V1, V2, V3 like this, you will get V4. So above will be S3. Now this is energy order for this one. Then later on what happens, say here you will get T1, T1 V0. This is V1, V2, V3, V4. V1, V2, V3, V4. So don't give more gap when if you are keep moving. Try to reduce the gap. So for your understanding purpose I am giving more gaps. So this become T2. This is T1. So T1 having variable vibration energy levels, then you will get T2. T2 adjacent there is a V0 is there. So from there onwards V1, V2, V3. Okay. So whenever if you are returning from vibration energy level to within the electronic energy level, this is called vibrational cascade. Don't write, just listen. So when excited molecule, if it is releasing energy in the form of heat by changing vibration energy levels within the electronic energy level, that is called vibrational cascade. De-excitation of excited molecule releases energy in the form of heat by changing vibration energy levels within the electronic energy level. That is called vibrational cascade. Then one more. So here I am writing S2. S2 to it is goes to S1. S2 to S1. Then how it is releases? It is going to release in the form of heat. Now it is also going to release in the form of heat only. What is this? Internal conversion. What is internal conversion? See here S2 to S1 or not? De-excitation of excited molecule or de-excitation of molecule releases energy in the form of heat by changing their electronic energy levels. During this process, multiplicity retains. Singlet to singlet only, and this is possible only with electronic energy levels only. Here only vibration energy levels takes place within the electronic energy level. Here electronic energy level only. S2 to S0 possible, S2 to S1 possible, that is called vibrational cascade. Okay, now here most important one is this, see. So here I am writing it is S1 and what is this? V0. So now here it is goes from here to here. This is most important one. What is this? This is called ISC. ISC, it is also releases heat. What is ISC? Inter-system crossing. Can you define what is inter-system crossing? De-excitation of a molecule releases energy in the form of heat. Releases energy in the form of heat by changing their multiplicity. Singlet converted to what? Triplet. Is it possible? No. It is a forbidden. Very slow process. Sometimes it may be possible, sometimes it may not be, sometimes it is possible. That is called ISC. ISC is a which decay process? Thermal decay process. It is a most important aspect in photochemistry. Okay. So what is vibrational cascade? What is vibrational cascade? De-excitation of a molecule releases energy in the form of heat by changing their vibrational energy levels within the electronic energy level. Only vibration changes, but this state is remain same. State never changes. S2 always S2 only. S1 always S1 only. Only vibration energy level changes. Then what about IC? De-excitation of a molecule releases energy in the form of heat by changing their electronic energy levels. What is ISC? Inter-system crossing. De-excited molecule releases energy in the form of heat by changing their multiplicity. It is the most important in photochemistry. It is a thermal decay process. It is a very slow process. It is a forbidden process. And many interconversions or different products are possible in this process. Okay. So these three are what? Thermal or photochemical? Thermal. Okay. Now see. What is this? What is this? Is it VC or IC or not exist? VC only. Remember this side, that side, both are same. Okay, change in vibration energy levels within the electronic energy level. So it is also VC. This question is given in exam. Even this also given in exam. Last year this is given. Now T2 to T1 they given exam. T2 to T1 conversion is A. Suppose if it is a heat system. If it is a heat system, T1 to T2 to T1 system, only electronic energy levels are changes. This is called internal conversion. Okay. Next. Now I am doing this one. See, now photochemically excited into higher energy level after reaches to variable higher energy levels. Okay. Now this is higher energy level S2 or you can take any one, even if any other higher state. Now it is whenever if it is coming back from higher to lower. This is called de-excitation. This is excitation, now it is de-excitation. De-excitation, if it is releases light, it is releases light energy. This is called fluorescence. This is fluorescence. Okay, now see, singlet to singlet or not, S2 to S1 or S2 to this one, this all are singlets. Now here see one more, I am writing T1 to S0, T1 to S0. This is also releases energy in the form of light. Here energy released in the form of light energy, but here see difference is, this is called, this is phosphorescence. So after reaching T1, if molecule reaches to ground state, during this if they releases light energy, that is called phosphorescence. If they release this, it is also what? Fluorescence. Fluorescence is allowed, phosphorescence is forbidden, because changing multiplicity or not. See, S2 to S1, singlet to singlet, but triplet to singlet, forbidden. Suppose when reaches to T2 to T1, if they release light, intersystem or internal conversion, if they releases heat, suppose T2 to T1, if they release light energy, what is that? Fluorescence. Singlet to singlet is fluorescence, triplet to triplet also fluorescence, triplet to singlet is phosphorescence, but they should release light. If you are saying the word fluorescence or phosphorescence, use light. See, triplet to triplet heat energy IC, triplet to triplet light energy. See, it is releasing energy in the form of heat. Now it is releasing energy in the form of light. Then what is the difference? T2 to T1 releases energy in the form of heat, internal conversion. T2 to T1 releases energy in the form of light. What is that? Fluorescence. This and this both are fluorescence only. This question is given. Today one question I given in your WhatsApp group, see that this is question only. So after this you see that question, right now you write down the all concepts, at last you see that question, then you will understand. So now I am going to give some definitions, try to understand. What is VC? What is VC? De-excitation of molecule release energy in the form of heat within the electronic energy level. What is internal conversion? De-excitation of molecule release energy in the form of heat by changing electronic energy level. So de-excitation of excited molecule releases energy in the form of heat by changing their multiplicity, that is ISC. This is most important. Okay, de-excitation of excited molecule to ground state by releasing energy in the form of light by retaining their multiplicity, that is called fluorescence. Inverting their multiplicity is called phosphorescence. Here absorption is equal to emission. Here emission is less, absorption is high, that is called phosphorescence. Phosphorescence is forbidden, fluorescence is allowed. So don't write this, first you write down definitions, then you write this. So first you write, keep heading vibrational cascade. So don't write the diagram, at last you write down after getting these definitions clearly. Vibrational cascade. So de-excited molecule release energy in the form of heat by changing vibrational energy levels, within electronic energy levels. De-excited molecule release energy in the form of heat by changing vibrational energy level. By changing vibration energy level. That is called vibrational cascade. So can you write example? You need to write the example here. S2 to V4. Now, is it S2 to V0 possible? Now I am saying it is vibrational cascade. Now how energy is going to be released? Energy in the form of heat. Is it exist? Is it vibrational cascade? Always singlet states are remain same. S2 to S1. S2 to S2 only. Okay. Suppose if I take S1. S1 to V2. Then S1 to V0. Possible? Yes, it is also vibrational cascade. Here energy released in terms of heat. So now see, this is S2 to V3. Now I am writing S1 to V0. Possible? Is it vibrational cascade? So if I say heat is releasing, here S2 changes to S1. No. Remember, it is not VC. Only singlet states are remain same. Only change in vibrations are observed. Singlet states are remain same. Suppose if you start with S1, it should be S1 only after this. If it is S2, start with final also S2. It should not change their electronic energy level. See, this is S2, it should be S2 only. Vibrations changes. Here S1, here also S1. Then change in vibration possible. Now here S2, S1. No, it is not VC. If there is any electronic energy level changes, that is called internal conversion. Clear? T2 to V4, heat energy released. T2 to V0. Possible? Possible or not? Yes, this is possible. T2 to V0, T2 to V4. Vibrational cascade. Is it possible? This is right symbol, which is possible. Is it possible? T2 to T2 same or not? Vibrations are changing. What I say, this T2 T2 same. S1 S1 same, S2 S2 same. But what do you observe here? V0 V4. This is excitation, not de-excitation. Jablonski diagram applicable for de-excitation. So don't go for excitation. Only whenever if you are coming down from uphills to low hills. So only that is possible. This is not a vibrational cascade. This is not possible. That is not VC. Wherever cross symbol I am writing, that is not exist. That is not VC. From this question is asking regularly. You may expect any DL question or even set examination, gate examination, everywhere Jablonski diagram first priority. Later on top reactions in photochemistry such as Narish 1, Narish 2, pattern-Buch reaction, dipymethane rearrangement, oxidipymethane rearrangement, most common. First you complete this. After all definitions you write down this diagram. Don't write first. Keep in your mind what is IC, VC, ISC, what is fluorescence, phosphorescence, then you can write at a time. This is IC, internal conversion. Over. Keep heading internal conversion, then write the definition. De-excitation of molecule release energy in the form of heat, same, by changing what they changes? By changing electronic energy levels. By changing electronic energy levels. Only electronic energy level changes. No vibrations, only electronic energy levels. De-excited molecule release energy in the form of heat. Here also energy releases in the form of heat by changing electronic energy levels. By changing electronic energy levels. S2 to V0, S1 to V0. Is it IC? IC or not? Yes, it is a example of IC. Now S2 to V0 I am converting into S0 V0. So I am writing releases in the form of heat. Is it IC? Not only to electronic energy level, from higher electronic energy level to lower, also possible. Not only with S2 to S1, don't think only adjacent electronic energy level. Non-adjacent electronic energy levels also responsible for giving IC. So this is also possible. Okay, T2 to V0 2, T2 to V0, T1 to V0. Energy release in terms of heat. Possible? Possible or not? Yes, it is possible. S2 to V0, S1 to V0. Internal conversion, heat is released. See, is it vibrations are same? V0, 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 V0 I written. But right now what I given? V2, V0. Is it electronic energy levels are changed or not? That is sufficient. If electronic energy levels are changes, no need to see vibration energy levels. And if energy release in terms of heat, that is called internal conversion. This kind of doubts you will get while choosing that particular option. If electronic energy levels are changes by releasing energy in the form of heat, blinded belongs to this case. S2 to V2. Now you will get T1 to V0. I am saying it is IC. Is it IC or not? IC or not? Singlet to singlet possible. Triplet to triplet possible. Singlet to triplet is not IC. This is not internal conversion. Multiplicity retains. So in this, after this you write down de-excited molecule in case of IC, it will retain their multiplicity. You complete up to here, that point I will give. That is a key point. De-excited molecule, if it is IC, that will retain their multiplicity. Singlet to singlet, singlet to singlet, triplet to triplet, singlet to singlet possible. Singlet to triplet, retaining or inverting? Inverting multiplicity is not IC. Clear? Right. Here you write one point. De-excited molecule retains their multiplicity. De-excited molecule retains their multiplicity. De-excited molecule retains their multiplicity. Then third one, it is most important one, inter-system crossing. ISC. Inter-system crossing. Right. See, it is thermal decay process. It is thermal decay process in which inversion of multiplicity is observed. Inversion of multiplicity is observed. Multiplicity changes in this one. It is a thermal decay process in which inversion of multiplicity is observed. See, it is most important deactivation for variable photochemical reactions. So for many variable photochemical reactions, it is the most common and most important step. If you want to get a different product, normally normal reactions never give this. Once if you convert ISC, you will get a different and unexpected products are expected. So that's why it is one of the most important step. ISC is most important out of these 5. Many miscellaneous reactions will be there only with ISC. Once if singlet converted to triplet, then you will get different answer. Complete different answer. That's why questions coming from triplet sensitizer. If they use this word, triplet sensitizer anywhere means different answer. Be careful. Photochemical you will get different answer only when if system changes, singlet to triplet. Okay? Right. See. De-excited molecule release energy in the form of heat by changing multiplicity. This is a key point. Is ISC. De-excited molecule release energy in the form of heat by changing multiplicity. Okay, is ISC. Is known as inter-system crossing. This one you need to remember. Singlet I am converting into triplet. Next, see, it is forbidden process. It is forbidden process. So I can say it is slow. Otherwise we can say very slow. Otherwise we can say delay process. But definitely possible, depends on gap. See, this reaction possible based on that gap only. You know, S1, T1 gap is there. ISC possible based on this gap. S1, T1 gap is there. If this gap is very high, very slow. Gap is increases, not possible. Some molecule ISC not possible. Some molecule slow, some molecule very fast. So that's why ISC changing multiplicity, that's why it is called forbidden. Remember, if which among the following is forbidden question comes, definitely belongs to ISC. ISC is a forbidden process. Is it not possible? Forbidden means always not possible? No. Forbidden means, what is the meaning of forbidden? So it is not a favorable process. Slow process, delay process, response very slowly. Sometimes not possible. ISC is possible always? Inter-system crossing possible always? No. Is it always slow? No. It is always fast? No. Means inter-system crossing may be fast, may be slow, may be delay, may be not possible. That all words indicates forbidden. Suppose if I use allowed means very fast. Allowed and forbidden. No problem with allowed, problem with forbidden only. Is it ISC forbidden or allowed? Forbidden. Say forbidden. Clearly written. It is a forbidden process. Forbidden means it may be slow, very slow, or not exist. Delay. Even sometimes not exist. ISC not exist. Some molecules. So don't think it is many meanings are there in this one. Now see, I can write like this: S0 V0, then followed by T1 V0. Possible? T1 V0. ISC. Now energy release in terms of heat. Possible? Yes, it is possible. Now I am writing S2 V02, T2 V0. Inter-system crossing. I am releasing energy in the form of heat. Possible? Possible or not? Yes, it is possible. Now S2 to V0. Now I am writing T1 to V0. Inter-system crossing heat. Possible? No, this is not possible. See, when S2 want to convert T2, first S1 changes to which one? T2. T2 converted to S2. S2 converted to T1. Long process. So normally this is not possible. ISC possible between two adjacent energy levels only. Only adjacent. S2 T2, S1 T1, S3 T3. Not between higher singlet, lower triplet, not possible. Indirectly possible. Indirectly means S2 to T1. Possible? No. S2 to T2, T2 to S1, S1 to T1. That is possible. But if what he was saying directly S2 to T1 possible or not? No. It is not possible. Over. Right, you write 1 point. Returning of excited molecule into ground state by releasing energy in the form of light. In the form of light is radiative. It is radiative process. Last one is thermal, non-radiative. Now it is photochemical process. Returning of excited molecule into ground state by releasing energy in the form of light is radiative or photochemical process. So in that first one, fluorescence. Fluorescence. See, it is photochemical process. Photochemical process. Now, it is allowed, comma, faster process. So it is most common rapid process. Most common rapid process in molecule. Most of the organic molecule, it is most common. It is photochemical process. It is allowed and faster process. Most common rapid process in molecule. So de-excited molecule release energy in the form of light. In the form of light by retaining multiplicity. So this is a key point here. So multiplicity is going to retain here. De-excited molecule release energy in the form of light by retaining multiplicity. Here key point is retaining multiplicity. If you forget this point, there is no difference between fluorescence and phosphorescence. Most common rapid process in variable organic molecules. De-excited molecule release energy in the form of light by retaining multiplicity. Okay, so in this process, see, absorption of light is equal to emission of light. Absorption of light is equal to emission of light. This is a key point. How much energy in the form of light absorbed by the molecule? Whenever if it is coming back to ground state, same amount of energy in the form of light is emitted. Absorption equal to emission in fluorescence. So I can write like this: S0 V0 possible. So it is returns in the form of light. Is it exists? S2 V0, S0 V0. Now it is coming in the form of light or not? Yes. So I can write S4 V3 coming down to S0 V0. Now it is coming in the form of light. Possible, releases light. S4 to S0 possible directly. Now S3 V4 to directly S2 V0. Now it is coming in the form of light. Change in any electronic energy level by retaining multiplicity by releases light is called fluorescence. Now even we can take T2 V02, T1 V0. Now it is released in the form of light. It is also called fluorescence. All are possible. So in exam they will ask which among the following is a fluorescence. 4 options they will give. Which among the following is phosphorescence? Like that 4 options they will give. Keep heading. Phosphorescence. Second one in radiative. Phosphorescence. Same. It is a photochemical process. It is forbidden. Slow and less common process. It is forbidden, slow and less common process. Here definition is remains same. De-excited molecule release energy in the form of heat, that is light. Now by inverting multiplicity. Inverting multiplicity. And in this one, emission always greater than absorption. Means it will absorb more. Sorry. Emission less than absorption. It will absorb more, emits less. Means some energy lost, right or not? How much it is absorbing? Same way if it is emits, that is called fluorescence. It is absorbing more, emits less. That's why emission less than absorption, which means more absorption, less emission. Fluorescence is a allowed process, but phosphorescence is a forbidden. Best example T1 V02 S0 V0. So now it is coming in the form of light. T2 V02 S1 V0. It is coming in the form of light. Reverse. Reverse to ISC. Reverse to ISC is phosphorescence, but their heat here light. So that is Jablonski diagram. Total 5 terms will be there: VC, IC, ISC, fluorescence and phosphorescence. You take this Jablonski diagram. So write clearly wherever I am writing heat, be careful. Heat, heat, this is heat. Here also it is heat, it is also heat. VC, heat. Here I have not written heat, you write down heat. This is light, this is light, this is also light. This diagram they are giving directly. They are mentioning letter A, B, C. Here they will write A, here they will write B, here they will write C. What is ABC? Open that question and see. Will you attempt that or not? This is last year CSR question. In your WhatsApp group I sent that question, just see this. In the Jablonski diagram given below, the initial excitation takes place from the singlet ground state to the second singlet excited state, S0 to S2. Match the processes to the events marked as ABC. Open that question in your WhatsApp and see the three possibilities. Three they given in Jablonski diagram. Three processes they given. In the three processes, you have to identify which is the correct among the three. So A they given, B they given, C they given. You can see this and you can also give that answer. Sometimes your options will decide the answer. See, A, B, C, 3 they given or not? Do you have that question or not? Do you have that question? Just see. What is A? Singlet to triplet. S1 to T2. So T2 energy is very less as compared to S1. Possible is there or not? Yes, it is possible. So S1 to T2 possible. Only when T2 energy less than S1. Clearly they given. See, T2 energy less than S1. S1 to T2 possible. So suppose if it is like this. This is S2. This is S1 and here I am writing T1 and here I am writing T2. What they given? S2 to T1 or S2 to T2 or S1 to T2. S1 to T2 they given. Suppose if they actually this is a real structure. Suppose if they given like this, S1 to T2 impossible. Lower to higher possible? No. So this S1 to T2 possible only when if this energy T2 energy should be less than S2 and S1. Then only it is possible from here to here also possible. This is a key point. Clear? So now energy of T2 less than S1. So A is what? What is A? Inter-system crossing. Is it thermal or photochemical process? Thermal. See, if you know this, you can neglect two options. So answer may be, is it internal conversion? No. Is it inter-system crossing? Yes. And it may be inter-system crossing. So which two options we can neglect? 1 and 3 we can neglect. Answer may be either 2 or 4. Now what about B? What is B? T2 to T1. See, now they not mention thermal photochemical. Based on options you need to confirm the answer. T2 to T1, is it spin retains or inverts? Spin retains. So what do you expect? Is it a second option phosphorescence or fluorescence? Fluorescence. Clear? Then what about last one? C. T1 to S naught, phosphorescence. Simple. Major problem is you will confuse with S1 to T2. That is a confusing point. This point already on the time I explained, but they are neglected. They are running and sir, how is S1 to T2, how it is possible means clearly was given T2 energy is less than S1, then definitely it is possible. I am not saying that always S1 to T1 possible. S2 to T2 also possible only when if T2 energy level is less than S1. Suppose if T2 energy level is greater than S1, not possible. So now what is correct answer? Answer 4. So this is 4 marks question on that time. Last year question it is. So that is end of Jablonski diagram. In your next class you will see the key concept ISC, intersystem crossing, how intersystem crossing helps to generate a new triplet state of inefficient molecule. Okay, we'll stop here. So evening schedule will be announced in your WhatsApp group. So tomorrow morning schedule also announced in your WhatsApp group only. Mostly same time, 10:30 to 1 you have a morning session. Evening session will be announced later. Okay, we'll stop here.